These are the notes for 3-3 on function notation. Function notation is just a more sophisticated way to write a function instead of using y. So one thing to remember is that f of x equals y. Okay, the domain is still all of the x values. That's going to be whatever's in parentheses. And the range is all of the f of x values, all of those y values. The notation f of x, we say f of x, and this just means a function in terms of x. If we have more than one function, then that letter f is going to change, and it's just how we label each function. So we can have f of x, g of x, h of x, j of x. You can have any letter, but we start with f because f stands for function. So first we're going to look at how to evaluate functions using function notation graphically, and then we'll transition to solving algebraically. So with graphically, we want to evaluate f of 1, meaning what is the value of the function when x equals 1? So to do this, on the graph to the right, we want to find where x equals 1. And then find where the graph exists when x equals 1. Okay, so all of these points on that vertical line are where x equals 1. There are 2 points up the graph. We have one open circle when y equals 3, and we have a closed circle when y equals 1. Those open and closed circles have the same meaning as they did in Unit 2 with inequalities. Open, it doesn't equal. Closed, it equals. So in fact, even though this fails the vertical line test, it intersects the graph at more than one place, it actually passes because that is an open circle. So this point here, the point 1, 1, is the point we want. When x equals 1, y equals 1. So f of 1 equals 1. For f of 2, so again, x equals 2. What does y equal? So find x equals 2. And then any point on that vertical line have an x value of 2. And again, we have a closed circle and an open circle, so we want that closed circle y value. So that point is the point 2, 3. So when x equals 2, y equals 3. So f of 2 equals 3. Okay, so this value is our x value. This value is our y value. Three and 4 are giving us the value of the function, meaning they're giving us the y value, and it's up to us to use the graph to find the x value. So in this case, what does x equal when y equals 0? So y equals 0 on the x-axis, and all the values here have a y value of 0. So it's this point here at 0, 0 that we want. So when x equals 0, y equals 0. Now for f of x equals 4, so what does x equal when y equals 4? What value of x gives us a function value of 4? So find where y equals 4. All of these points on this horizontal line have a y value of 4. And find where the graph exists. The graph exists right here at this point, which is -2, 4. So when x equals -2, y equals 4. In function notation, f of -2 equals 4. Okay, so that's using the graph to evaluate using function notation. You're either given the x value and it's asking you for the value of the function, meaning that y value, or it gives you the value of the function, meaning that y value, and it wants you to find the corresponding x value. With number 3, we're comparing two different helicopter flights. Okay, the graph shows the number of miles a helicopter is from the destination after X hours on its first flight. Okay, so this is talking all about our first flight, that graph there. And its distance, but the reason it's decreasing is because it's the distance from from the destination. So as the time increases, the distance from the destination is decreasing. You're just getting closer to where you're going. So this graph, we want to look at when the distance is 0, meaning you're there, and it took 3 hours for the first flight to reach its destination. On the second flight, a helicopter travels 50 miles farther and increases its speed by 25 miles an hour. That's just information about the function they're providing. So the second flight is given to us as a function as opposed to a graph. Okay, so what we want to do is we want to graph this function on the same graph and compare how long it takes to get to the destination. So to graph a function, the only strategy we have right now is to create a table of values. And it's honestly always a good place to start to help organize your thoughts. So we have our x column and we have our f of x column, right? That's our y column. And the first flight, the graph, it's using, let's use values 0, 1, 2, 3, because that's on the first flight as well. It will be nice to compare using those values. So now we want to evaluate this function for this given domain. When x equals 0, how far are you from the destination? When you traveled 1 hour, how far are you from the destination? 2 hours, 3 hours. And we'll compare. So we want to use the function and substitute these x values. I'm going to get this table all set up to just plug and plot. Okay, we're going to plug the values in, plot the points. So let's start when x equals 0. After 0 hours, the helicopter is 350 miles from the destination. 0, 350. So make a point on the graph there. After 1 hour, the second flight helicopter is 225 miles away from the destination. After 2 hours, it's 100 miles away from the destination. And after 3 hours, well, this results in a negative number, which means that most likely the second flight got there faster. But let's graph and see. So we can't plot that point because it's negative, and a negative range value does not make sense in context. So we're just going to take the 3 points that we already have plotted and graph them. So we want to do a line as straight as we can. So what we're looking here is we're looking to compare the x-intercepts. These are the x values when the function equals 0, when y equals 0. So the first flight took 3 hours. The second flight took less than 3. We're not sure exactly what it is, but we can tell that that intersection point is less than 3 hours. Which made sense why we got that negative 25 value after 3 hours. Okay, so graphically, we know that the second flight got there sooner because it intersects the x-axis before the first flight did. Okay, it got to destination equals 0, it got to that distance from the destination equals 0 sooner than the first flight. Okay, so that distance, that y value, f of x, that equals 0. Okay, when that happened, the second flight had a smaller x value. It had fewer hours. So that's how we would determine who got there faster graphically. We can also do it algebraically. Now, we don't have a function for the first flight. However, it's pretty clear that it got there in 3 hours. We do, however, have a function for the second flight. And that's f of x equals 350 minus 125x. So algebraically, we can find the value of x that makes this function equal to 0. So we want to find out, when does f of x equal 0? What does that x value equal? How many hours does it take for the distance to be 0? So we want to substitute the value of f of x equals 0 in for f of x. And from here, we're solving this equation. Our first step would be to subtract 350 from both sides. And then divide by negative 125. And x equals 2.8 hours. So that's how we can determine algebraically who got there faster. Determine what the x value is to make that function equal to 0. And to do that, set the function equal to 0 and solve for x. I think evaluating functions graphically is much more challenging than algebraically. So I think you'll find the rest of this section to be a little more straightforward and have more computation involved. So using function notation to evaluate, remember, you're not solving for f. We're not solving a multivariable equation. Okay, we're just finding the value of f of x with a given x value. Or maybe we could be finding the x value with the given f of x value. We're either solving for x or y. So I'm going to color code these functions here. We have two functions. One is labeled as f of x. The other is labeled as g of x. Again, f and g are just a way that we can name these functions. So evaluating for f of 2, when x equals 2, what is the value of the function? So we want to take the function and we want to substitute the value of x equals 2 and find out. Okay, negative 8 plus 8 is 0. So f of 2 equals 0. Okay, when x equals 2, y equals 0. The value of the function when x equals 2 is 0. Now for the g function, we want to evaluate when for g of 0. What is the value of the function when x equals 0? One half times 0 is 0. 0 minus negative 3 is negative 3. So g of 0 equals negative 3. Evaluate f of negative 1/2. What is the value of the function when x equals negative 1/2? Negative 4 times negative 1/2 is positive 2. And 2 plus 8 is 10. I'm just going to quickly rewrite these functions so I can see them when we do the next row of problems. Evaluate g of 4. When x equals 4, what's the value of the function? Substitute the value of x equals 4 and evaluate. So g of 4 equals negative 1. F of 0, when x equals 0, what's the value of the function? So use f of x, substitute x equals 0, and evaluate. So f of 0 equals 8. And last one for given x value, g of negative 8. So again, use the g function, substitute the value of negative 8, and evaluate. Equals negative 7. So when x equals negative 8, the value of the function is negative 7. Okay, again, just a reminder, x, y, x, y, x, y. So one benefit of using function notation, especially when you're doing an applied problem, is instead of just giving random answers as a solution, you know how you got that specific output value. For instance, if we go back to the helicopter flight, what I could say is for the first flight, well, it took 3 hours. to get to be a distance from the destination of 0. For the second flight, f of 2.8 equals 0. Okay, so it gives you the input value and the output value as the solution. Has a little more information to it. But back to evaluating. So these 6 problems, we were given the x value, and it was up to use whatever function it was referring to and find the value of the function, finding that y value. Now the next 6 are the opposite. We are given the value of the function, and we need to find the x value. So I'm going to rewrite these functions again so they're right in front of us. I think that will help. Okay, so f of x equals 16, meaning the value of the function is 16. But what x value got us 16? Well, substitute 16 for f of x and solve for x, the same way we did with the second flight for the helicopter. Okay, so we replaced f of x with 16, and now we want to solve for x to determine our input value. So we get an x value of -2. So now let's just practice rewriting this in function notation the same way you would on an assessment. Okay, so f of -2 equals 16. I think that helps bring it on home. So when x equals -2, the value of the function is 16. Let's try g of x. So g of x equals 0. So we're going to substitute 0 for g of x and solve for x. So we would add 3 first. One half x. So to solve, we would multiply both sides by 2. And get x equals 6. So the function notation would be g of 6 equals 0. Last one, f of x equals -4. So again, we're going to substitute -4 in for f of x and solve for x. We've done a lot of practice on solving, so this is a great chance to put those skills to work. So we get an x value of 3, so f of 3 equals -4. So those are the notes for 3-3 on function notation. We learned how to evaluate function notation algebraically as well as graphically. You're either given the x value or you're given the value of the function, the y value, and it's up to you to find the missing part.